Suppose we have a list of numbers. We want to find the best way to describe those values. We can use several different measures in order to do that. Here's three: the mean, the median, and the mode. You're familiar with these, you work with these in elementary school, but let's take a couple of moments to review what they are. The mean is simply the average. To find the average of a set of numbers, you simply add them up and then divide by how many numbers there are. In this case, there's 10 numbers, so I divide by 10. Then I simplify, and I find that the average value is 13. The next measure that we have is the median. When we have the median, we simply are looking for the number that's in the middle. We take the numbers, line them up from smallest to biggest, and then we count our way in. We take the number that's right in the middle, and that's called the median. In the event of a tie, such as this example you see here, where we have 10 and 15 both in the middle, we simply take the average. We add them together and divide by 2. In this case, our median is 12.5. Finally, we can't forget the mode. The mode is simply which one happens the most often. When we're looking for the mode, we list our numbers from smallest to biggest and then count which one has the greatest frequency. Here, the number 10 appears 3 times, and the number 15 also appears 3 times. In this case, we have 2 modes. The modes are 10 and 15. It's important to note that if you did have no number that repeated more than once, that you would have no mode. So if there are no repeats in your list, you have no mode. So with all these measures, how do we know which one is the best to describe our information? And why exactly do we need more than one anyway? Well, let's take a look at a situation. Here we have the grades that a class earned on a knowledge quest. Grades went from 65 all the way up to 97. We found the median and found that it was 84%. Half the class did better than 84. I also found the mean, the average. It was 83.4. The median and the mean were pretty close. If someone said, "Mr. Dory, how did everyone do on the knowledge quest?" I'd feel okay saying, well, the average was around 84. Some people did better. Some people did a little bit worse. But what happens if you have one grade that's really not close to anything at all? What if, for example, instead of the 65, you had a 0? Well, when I calculate the median and the mean, I find that the median is still 84. But notice the mean, the average, has moved all the way down to 79. 79 really doesn't represent the data at all. In fact, there's only a few people who did worse than 79. Almost everyone did better. In this case, the median is the best choice to describe the data. I'd feel better saying, grades were around 84. That describes, some grades are lower, some grades are higher. But to say they're around 79, that just doesn't make much sense. So here's a few things to keep in mind. If you want to work with the mean, well, it's very popular. People love the word average. However, if you have outliers, a number that's extremely low or extremely high, it's going to have an impact. It's either going to raise your average up or raise your average down, which means it may not fully describe the data. The median is not as popular. You never really hear people talk about the median, at least not nearly as often as you do the average. However, it's a great tool because if you have 1 or 2 numbers that are far out there, they don't have a very high impact on the median. Finally, the mode. Well, outliers have a very low impact on the mode also, but it's not very popular. Mode is really mostly found when you're looking for the frequency of something, such as favorite colors or favorite flavor of ice cream. So let's take a look at some examples. Here's the data set that we were working with before. We already found the mean, the median, and the mode. We found those through our first examples. In this case, which of these represents the data the best? Well, notice 13, 12 and a half, and even the modes 10 and 15 are really close to the middle. I would say in this case, all three represent the data fairly well. In example 2, we want to find the value of x so that the average of 8 and x is the same as the average of 27 and 5. So the first question is, what is the average of 27 and 5? Well, the average of 27 and 5 is 16. So the average of 8 in x is going to be 16 also, because we want 8 in x to have the same average as 27 and 5. 8 plus x divided by 2 equals 16, and now I can solve the equation, and I find that x is 24. The numbers 8 and 24 have the same average as 27 and 5. In example 4, we have a set of data. They say that we're going to add 3 to each one. 6 becomes 9, 7 becomes 10, 8 becomes 11, and so on and so forth. What happens to the mean, the median, and the mode? Well, notice here when I calculate my new numbers, the mean is 3 higher, the median is 3 higher, and the mode is also 3 higher. When we added 3 to each of the numbers, all three of the measures also increased by 3. In example 5, we're going to take the same numbers, but instead of adding to them, we're going to multiply. Here, we multiply each number by 2, and then we find the new mean, median, and mode. In this case, the mean, median, and mode were all multiplied by 2, just like each of the numbers in the data set was. Finally, on example 6, here's an example that can actually be useful. Bob received some scores on a biology test, 72, 86, 92, 63, and 77. He has one more test, and he wants his average to be 80% for the quarter. How can we find out what grade he has to get? Well, we're simply finding the average. We have the first 5 test scores, and then the 6th test, which will become x. We take those numbers, add them up, and divide by 6. We set that equal to 80, and now we solve the equation. In order for Bob to have an average of 80%, he needs to get a 90 on the last test. This is what you need to know about working with measures of central tendency.